Hi, Xuelian Li. Now I'm doing the first question of homework 3. Before we solve the question, there are a few things we have to know. As we all know that the sum from k equals 1 to infinite of p to the k, it equals 1 over 1 minus p. And differentiating both sides with respect to p, we can get that the sum from k equals 1 to infinity of k times p to the k minus 1, it equals 1 over 1 minus p squared. And if we want to solve the sum from k equals 1 to infinity of k squared times p to the k minus 1, we have to multiply the p. We have to multiply the p on both sides of this function, and we can get the sum from k equals 1 to infinity of k times p to the k. It equals p over 1 minus p squared. And similarity differentiating both sides with respect to p, we can get this function equals 1 minus p squared over 1 minus p to 4. And it is the same with mentioned above, like we have to multiply by p on both sides, and we can get from the sum from k equals 1 to infinity of k squared times p to the k equals p times 1 minus p squared over 1 minus p to the 4. And differentiating both sides with respect to p, we can get the sum from k equals from 1 to infinite of k to the 3 times p to the k minus 1. It equals p squared plus 4p plus 1 over 1 minus p over to the 4. And we have solved all these functions. Now, the question is p of k x equals k equals b times k times p to the k minus 1, and k equals 1 from 1 to infinite, and p is between 0 to 1. And the first question is, let us find b. And according to the properties of discrete random variable probability function, we can get that the infinite from the sum from k equals 1 to infinite of p x equals k, it equals 1. And we can rewrite it as the sum equals 1 to infinite of b times k times p to the k minus 1 equals 1. And we have already solved this function. We have already solved the from k equals 1 to infinite k times p to the k minus 1. We have already solved it. It is equals to this one, like 1 over 1 minus p squared, and we need to put this result into this function, and we can get b equals 1 minus p squared. b equals 1 minus p squared. And the second question is, let us find the expected value e of x. from the formula, the e of x equals from a sum from k to the 1 to infinite of xi times pi, and we can rewrite it as b times a sum from sum of k from 1 to infinite of k squared times p to the k minus 1, and we have already solved this one above, and it equals 1 minus p squared and over 1 minus p to the 4. And we have to the other thing we have to is put this result into this function, and we can get the e of x equals 1 plus p over 1 minus p. And the third question is, let us find e of x squared. E of x squared is from the sum from k from 1 to the infinite of xi squared times pi. You can rewrite it as b times sum of k from 1 to infinite of k third times p to the k minus 1, and this one we have solved that it equals p to the p squared plus 4p plus 1 over 1 minus p of 4 power, and just need to do is put this result into this function, and we can get e of x squared equals p squared plus 4p plus 1 over 1 minus p squared. And the first question is, let us find ex squared minus ex squared. And all the thing we have to do is just put the result we have solved above into this function, and the result is 2p over 1 minus p squared. And the fifth question is, let us find the p probability of k equals 1 in the condition of k between 2 and 5, where p equals 1 over 3. And we can know that when k greater than 5 or k smaller than 2, there is no intersection between k equals k and k between 2 and 5. So the probability is the probability equals 0, and when k is between 2 and 5, the probability is equals probability x equals k over probability of k between 2 and 5, and we have to put the function into this function, and where p equals 1 over 3, and the result is 81 over 98 times k times 1 over 3 to the k minus 1, and that's all.